Hello, in this video we will see local binary patterns and how this technique works. So this is a popular technique we use today for the face representation or image representation and its classification. So we have a wide range of application where we can use the local binary patterns, like in the object detection, face recognition, texture classification, facial expressions recognition. So like that, we have a wide range of applications where we can use the local binary patterns. So how it works, it uses a 3x3 window from the image and we will extract an LBP code. We have the three parameters on which LBP work. It's the center pixel value, the radius, and we have neighbors and XY grids. As you can see here in this image, we have the different pixel values. These are the pixels having the different values. So in this video, simple, we will learn how we will compute these values, or how the LBP technique or the algorithm compute these values. Then you can see the different patterns created here. So we are going to learn how we can compute these values using LBP. So next, this is a LBP operator. We have the value of n is from n to 7 and we have in minus ic. So here ic is the center pixel value, that is the radius. In is the neighbor pixel values, that are the pixel values around the center pixel value. Value of g is computed by this. If g is greater than or equal to 0, then we will put 1. If it is less, then 0. For example, we took these pixels from an image. Now we will compute the values for this. Here IC, that is the center pixel, is 4 and its neighbors are here 5, 9, 1, 6, 3 up to this. We have 7 neighbors. I0 is 5, I1 is 9, I2, I3, I4, I5, I6, I7. These are the neighbors and this is the center pixel value. So we will compute these values using this equation. So let's see how it works. First, we will compute for n equal to 0, as we have the range from 0 to 7 because we have 8 pixels only. 9th one is the central pixel. So put the value of n is 0 in this equation. So after putting the value, you can see we will put the value of I0, that is 5, value of IC, that is 4. Then here you get, after compute this value, we got 1. Now we'll compare here the result. You can see 1 is greater than 0, then we will assign 1. Done. So here instead of 5 we will put 1. Same we will do for all the values of n. Now for n equal to 1, put the value of n 1, value of I1 is 9, put the value here, compute it, we got 10. 10 is greater than 0, put 1. Done. Next, value of I2 is 1, put the value of n equal to 2, I2 is 1, compute it, we got minus 12, and you can see minus 12 is less than 0, so we will assign 0. Next, the value of I3 is 6, put the value here, I3 is 6, compute it, we got 16, and 16 is greater than 0, put 1. Done. Next, we will compute for n equal to 4 and the value of I4 is 3, compute the value, and you can see we got minus 16 and minus 16 is less than 0, so we will put here 0. Next is I5, that is 2, put the value, compute the result, we got 0. 0 is equal to 0, so we will put here, so sorry, we got minus 32 and you can see here minus 32 is less than 0, so we will put here 0. Next is for n equal to 6, put the value, I6 is 7, IC is 4, we got 192, that is greater than 0, so we will put here 1. Next, for I7 we have the value for I7 is 4. Compute the value, we got 0, and you can see here if G is either equal or greater, then we will put 1. Here 0 is equal to 0, so we will put 1. So we got these patterns, the pixel values for this. Okay, next we have another method. You can compute these values by comparing the neighbor values with the center pixel value. Here you can see these are the neighbors and this is the center pixel value. If the center pixel value is greater than the neighbor, then we will assign 0. If the neighbors are greater than the center pixel value or equal, then we will put 1. For example, 10. Here 10 is greater than 9, so we will assign 1. So you can see here 1. For 6 is less than 9, so we will put 0. You can see here. So next step is we will extract the binary numbers from this. So we will extract from this side. Done. So 1 1 0 1 0 0 1 1. Done. So this is the binary number we generated. Now we will convert this binary number into the decimal number. So compute the value, and we got LBP code generated, that is 211. This is the decimal value. So as I told you that using this technique we will compute the values for the central pixel. So like that we will do this for all the image. This technique, that is LBP, will create the patterns for this. So these are the values they computed. So like that we will compute all the values. So in the starting of the video I told you that it is used in the different applications like in the face recognition, face detection. So these are the patterns that we have extracted from the digital image. As you can see here in this image, I took a digital image, then I apply LBP algorithm on this digital image, then extracted its features, then I apply a face detector and we got the detected face, and this is the histogram. Same I did for this image. We took multiple people. Here you can see in this image, then we extracted the patterns using local binary pattern technique, then we apply a detector and you can see we detected the face. So this is a simple technique or the algorithm we are using today for the face detection. If you have any question, then please comment below, and thanks for watching this video.